Hey guys, Bhaswat here. So this is my new channel, and first of all let me give you a brief about what all I am going to do in this channel. So this is going to be a hardcore problem solving channel. I am going to bring the most beautiful and elegant problem from all around the world, including the exams like Putnam, IIT JEE India, and various Olympiad, including International Mathematics Olympiad. And I am going to discuss all the beautiful solution with you guys. So this channel is relevant for all the people who are preparing for Olympiads, IIT JEE, or anyone who is just interested in mathematics or want to learn some math for fun. Okay, so that's the intro, and without wasting any further time, let's dive into the problem that we're discussing today. So the problem we're discussing today is a very famous problem from Indian IIT JEE. It was there in the paper in the year 2000, and it was for 6 marks. It was notoriously hard back then among even all the teachers. They used to be like, this problem is just too hard for someone studying in class 11 or 12. But today I'm going to demystify that idea, and I'm going to prove to you that if you approach it correctly, even someone studying at a level class 8 or 9 can solve this problem quite easily. Okay, let's get started. So what the problem is saying is that we are given this inequality: root over 4n plus 1 is less than root n plus root n plus 1, which is less than 4n plus 2, and we need to prove that this greatest integer function of root n plus root n plus 1 is equal to greatest integer of 4n plus 1, and many people know it as the floor function, and it's the same thing. And let me explain briefly what this function do. Okay, so this function takes a real number x and it inputs the integer which is less than equal to it, and the largest integer which is less than equal to it. Okay, so let me just explain with a few examples. Suppose floor 2.5. What do we get? We get 2, because 2 is the largest integer which is less than this 2.5. Okay, now suppose 2, what will be the value? This will just be 2, because this fetches the integer which is less than equal to the input and the greatest amongst all the integers that satisfy this particular condition. Okay, so suppose now let me ask you a question. Okay, so what would be the greatest integer value of minus 1.2? Okay, so pause the video and try to give me an answer. Okay, so let me tell you the answer. It is minus 2. So if any of you have said that it's minus 1, then it is not correct, because if you see in the number line, here we can find minus 1.2, right? Here is our 0, here is our 1, sorry, minus 1, and here is our minus 2, and here is our minus 1.2. and if you see the integer just near to it, right, to the left, so this is clearly minus 2, right, because minus 1 will be actually greater than minus 1.2, so this won't be the answer. Okay. So let me just erase this and I'll get back to, oh, I'm sorry about this. Okay, So take a moment to think about how to approach this particular problem, right? So we are given this particular inequality, right? And we are asked to prove this equality. So first of all, let's see what is given, right? If something is given, then obviously we have to go from there to this, right? And first of all, let's play an investigator, okay? Shall we? Let's see. Can you see this root 4n plus 2? Yes. And you can't see any 4n plus 2 here, right? So where did it go? It is not used here, right? So somehow indirectly we will have to use this particular hint that while coming from here to here, we have to stress on this thing as well, even though it's not here, okay? So, and anytime you see any inequality like this, you have to remember something called a sandwich theorem, okay? Suppose A is less than B is equal to C, okay? Suppose after doing certain operations which preserves this inequality, A goes to P and C also goes to P, and by that theorem it says that B should also go to P, okay? Now let us observe a few facts, okay? First of all, let us take certain examples of what 4n plus 1 and 4n plus 2 would be. And even before taking examples, we can clearly see that 4n plus 1 and 4n plus 2 has a difference of 1, right? If you think about it, because this is 4n plus 1, this is 4n plus 2, right? They have a difference of 1. And if we take square root of them, then whatever we get, their difference would be even lesser than 1, okay? Suppose two number, okay, they have a difference of 1. Suppose 2 and 1. If we take square root of them, this would be 1.41 and blah blah blah, and 1 will have a square root of 1. And if we take difference of these two numbers, then we get 0.41, right? And this is clearly less than 1. Similarly, even if you take big numbers 25 and 26, and if you take their difference, then also you will realize is that their difference, if you take the square root of 25, this would be 5, right? And if you take square root of 26, then you will get 5 point something, okay? So it won't be 6, because if you see this square of 6 is 36, so the difference is obviously would be less than 1, right? Now we need to prove it rigorously, okay? First of all, let's prove that 4n plus 2 minus root over 4n plus 1 is less than equal to 1. Now if you remember, we have this equality, okay? A square minus B square is equal to A minus B times A plus B, right? And from here we can write A minus B to be A square minus B square divided by A plus B, right? So let me clear this for the moment and let us write whatever we got, right? We got 4n plus 2 minus 4n plus 1 is equal to 4n plus 2 minus 4n plus 1 divided by 4n plus 2 plus 4n plus 1, right? Okay, this is pretty easy. If you see, this would be just 1 and 1 divided by something greater than 1, clearly, right? Because n belongs to natural number, so this whole thing would be greater than 1, so this whole thing should be less than 1, right? Now let's see some particular cases, okay? And before doing that, let us just write it in some corner, whatever we got till now. Okay, first of all we got that 4n plus 2 minus 4. Okay, let me clear this first and then let me write down, because that would be much easier to keep track of, right? 4n plus 2 minus 4n plus 1 is less than equal to 1, right? And next, let's see whether we can put the integer inside root over 4n plus 1 and root over 4n plus 2. Why we are interested in that? Because see, if we can somehow establish that there is no integer inside this one and this one, then we can really get into this greatest integer part. Okay, and we can see if there is no integer, then both of them will have to fall back to the same integer or something similar. Okay, first of all, let's see whether we can fit in an integer in the middle or not. Suppose there was an integer. Okay, there was an integer which is, this integer is, suppose let it be p. Okay, this is less than 4n plus 2 and greater than 4n plus 1, and if we just square them, what we get is that 4n plus 1, this, right? And now if we think about it, if p is an integer, then p square would have to be an integer as well, right? But these two have a difference of less than 1 and both of them are integers. So if two integers which have a difference of less than 1, can there be another integer in between? No, right? So even these two cannot have any integer in between them, because if they have an integer in between them, then these two will also have an integer in between them, which we just showed to be impossible, right? Okay, so I think after getting these two things down, we are pretty close to the solution. Okay, let us clear it one more time and see case by case. Okay, suppose root over 4n plus 1 is integer. Okay, then we know that greatest integer of 4n plus 2. Okay, let's not get into greatest integer now, let's just see 4n plus 2, root over 4n plus 2. Okay, now as we know, the difference between this and this is less than 1, and let's see in the number line. So this is some integer, okay, I, and the next integer would be I plus 1 at an interval of 1, right? And suppose this is root over 4n plus 1. Okay, this point is our 4n plus 1, and 4n plus 2 will have to lie somewhere in the middle, because the difference of root over 4n plus 2 and root over 4n plus 1 is less than 1. So root over 4n plus 1 will have to lie somewhere in the middle of root over 4n plus 1. Let me write down, this is 4n plus 1, and this would be our root over 4n plus 1 plus 1. Okay, assuming 4n plus 1 is an integer, then we can clearly see that greatest integer of root over 4n plus 2 would also be root over 4n plus 1, because the integer which is next to it to the right hand, to the left hand side, which is root over 4n plus 1. So what we got is that we got this, right? And obviously if this is an integer, then if we take greatest integer also, it will remain the same, right? And now think about it, if this one, if we are taking greatest integer, this is equal to the greatest integer of this, and this comes in the middle, right? So automatically the greatest integer of this entity will have to be equal to this two, right? Because it's squeezed between these two. So this would be equal to root over n plus root over n plus 1. Okay, so what we assume this to be integer in the first case. Okay, in the second case, similarly, we can assume that 4n plus 2 is an integer. Okay, suppose 4n plus 2 is an integer. Let me draw it one more time. Okay, So here is our root over 4n plus 2. Okay, so if we see now, 4n plus 1 will lie somewhere here, right? Because the difference is less than 1, we would not reach root over 4n plus 2 minus 1, as we have already seen that the difference of root over 4n plus 2 and root over 4n plus 1 is less than 1. Okay, so if we take greatest integer of this number, we are going to get 4n plus 2 only, right? Because it's an integer, it would be the same as itself. And if we see now root over 4n plus 1, okay, greatest integer of it would clearly be greatest integer of 4n plus 1 root over, this would be equal to 4n plus 2 minus 1, correct? Because this is the integer right next to it, to the left. Okay, similarly p lies between 4n plus 2 and or root over 4n plus 2 and root over 4n plus 1. So even its greatest integer would be this same number, right? And again in this case also you can see that root over 4n plus 1 and this entity, they have the same greatest integer. Okay, so we have seen the case of this being an integer, this being an integer. Can they both be integer at the same time? No, they cannot, right? Because as you can see that their difference is less than 1, right? So they cannot be integer at the same time. And if we see none of them are integers, right, that would be the most interesting case. And if we see that none of them are integer, let me draw the number line one more time. So if none of them are integer, then this is root over 4n plus 1. If this is any integer I and this is any integer I plus 1, then I am claiming that root over 4n plus 2 will also live here. Why? Because we just proved that between these two there cannot be any integer, right? We took the example of p and we showed that p cannot lie between these two, because if p lies between these two, then if you square it, then you can see that p is lying between two integers, which is another integer, and these integers are separated by just 1, which is impossible. So these two are also going to, there won't be any integer in the middle, so they will live in the same space, right? And our Mr. This guy, okay, let's call it x. So x is also going to live here, right? Here I probably called this guy p by mistake, so here also it would be x, okay, if you remember how we discussed this whole case, okay. And now you can see that this guy, if you take greatest integer, this will be I, and for this x also this would be I, and again this case is valid, right? So I think we have exhausted all the cases, and by exhausting all the cases we have proved that this is indeed the case. See, we did not really use a lot of things to prove this supposedly, you know, notoriously hard problem of IIT JEE 2000. All we used is that root over 4n plus 1 and root over 4n plus 2, these two, they cannot have any integer between them. And the second thing we have proved is that the difference, whatever the difference is, it is less than 1. And using this two fact only, we are able to prove it quite easily. And I am pretty sure that even if any kid of class 8 or 9 is watching this right now, they would be, even if they write it down patiently, and even if required, they can play the video multiple times. And even then, if they have some doubt, and this is not for like people of student of class 8 and 9 only, anyone who is having any doubt, you can write it in the comment section. I'll try my best to explain it to you. And so I'll come with new problem every day or every alternate day. I'll try my best to search for problems like this, which are very elegant. If you can come up with the right approach, they're not hard or there's not much computation, but this is going to be very useful to develop this habit of problem solving or logical thinking, right? So I'll see you in the next video. Till then, take care. Bye bye.